Hello friends. Now that we've done a few sessions on factorization, let's go over some questions to see how to use the different techniques of factorization. So let's try and factorize 1 plus 2ab minus within the brackets a square plus b square. And these are the choices. Now let's look at the second question. We need to factorize x raised to power 4 plus 3x cube plus 3x square plus 3x plus 2. And here are the options. Let's now go over to the third question on factorization. And the question is, we need to factorize x cube multiplied by y minus z plus y cube multiplied by z minus x plus z cube multiplied by x minus y. And here are the options that we have. Now let's look at the solution for the first question. The question is factorize 1 plus 2ab minus within brackets a square plus b square. So now if we see, we can see clearly here that if we bring this 2ab inside the bracket, we will be able to use some identity. So that's what we do. Because we have a minus sign outside of the bracket, we bring this 2ab inside the bracket and we make it minus 2ab. So now using the identity a minus b whole square is equal to a square plus b square minus 2ab, we make this a minus b whole square. So it becomes, the given expression becomes 1 square minus a minus b whole square. And why do I write 1 square? We'll see in a minute, but 1 square is same as 1. So now we use another identity here, which is a square minus b square is equal to a minus b multiplied by a plus b. So in that expression we use this identity and it becomes 1 minus within brackets a minus b and multiplied by 1 plus a minus b. So we get the final expression as 1 minus a plus b multiplied by 1 plus a minus b. So that's the final factors. These are the final factors for the given expression, which was 1 plus 2ab minus within brackets a square plus b square. So option C is the correct answer. Now let's look at the solution for question 2. And the question is, we have to factorize this expression. So now the first thing that we do here is we split the middle term 3x square into 2x square plus x square. And now we see that we can club the first 3 terms together and we can club the next 3 terms together. In the first 3 terms we can take out x square common and then we're left with x square plus 3x plus 2 within brackets, and the last 3 terms are same as the term which is left, the expression which is left in within brackets for the first 3 terms. So we can take out plus 1 there and we get x square plus 3x plus 2 within the brackets, and using the distributive law here we make it x square plus 1 multiplied by x square plus 3x plus 2. Now we can see that this expression is also factorizable. So what we do here is we again split the term 3x here and we get the next expression which says x square plus 1 multiplied by x square plus 2x plus x plus 2. So now again we take the first 2 terms together and the last 2 terms together and we take out x from the first 2 terms and it becomes x multiplied by x plus 2 plus 1 multiplied by x plus 2. And again using the distributive law it becomes x square plus 1 into x plus 1 into x plus 2. So the given expression can be factorized into x squared plus 1 into x plus 1 into x plus 2, and the option B is the correct answer. Now an important thing to note here is, instead of pairing up this expression, pairing up the terms in the way we've done, we could have done it in a slightly different way. What we could have done is, we could have combined the first and the fourth term together, the second and the fifth term together, and third and the sixth term together. If we could do that and we start factorizing with that also, we'll get the final result as the same, but the middle steps, the steps in between, starting from step 2 to the fifth step, would be different, but the final result would be the same. So here in this expression, what we can we clearly see that there may not be just one possible way of factorizing. The techniques that we use could vary. So we could use two or more different methods of doing the same thing, but the final result of factorization will always come out to be the same. Let's now look at the solution for question 3. So this is the question. Now we simply open the brackets here. We are not doing anything else. We just opening the brackets. And the first thing that we note here, the expression that we need to factorize is clearly a cyclic expression. So by cyclic expression, we said that the expressions where we can obtain the second term and the third term and the other terms by replacing the variables in the first term cyclically. So if we see in the first term, which is x cube multiplied by y minus z, if we replace this, if we replace x with y, if we replace y with z, and if we replace z with x, we get the second term. And similarly, we can obtain the third term also. So we can clearly say that the expression, the given expression, is a cyclic expression. So we'll use the techniques that we used in factorizing the cyclic expressions. So as we said, we'll rearrange the terms according to the decreasing powers of one variable. So in this case, we've chosen the variable as x. So we say we keep the x cube terms first, and then x terms which have a degree of 1 for x after that, and then the terms which have no x in them. So now we take the x cube common and we get y minus z here. And similarly, in this third and fourth term, we take the x common and we get y cube minus z cube. Plus in the last two terms, we take out yz common and we get y square minus z square. Now we'll use the identity that we know, y cube minus z cube is equal to y minus z multiplied by y square plus z square plus zx. And we use the second identity for y square minus z square, which is equal to y minus z into y plus z. So now we can clearly see from this expression that y minus z can be taken out from the complete expression. So here is what we get. We take out y minus z, and then we get x cube minus xy square minus xz square minus xyz plus y square z plus yz square. We've just opened the brackets after taking out y minus z from this whole expression. Now we arrange them in the order where y square terms are taken first, and then the terms with y, and then the terms without y in them. So we repeat the steps that we've done in the initial three, four steps. We repeat them, and we again take out y square here, and we left with z minus x in the bracket. We take out yz here, and we're left with z minus x again in the bracket. And here we take out x, and we're left with z square minus x square. And we again use the identity for z square minus x square, and we make it z minus x into z plus x, and then we can take out z minus x out from the whole expression. So it becomes y minus z into z minus x, and then y square plus yz plus minus xz minus x square. So now we've arranged them in the order of decreasing power of z. So we keep the first two terms with the z and the last two terms as other terms without z. So again we take out z, and then we get left with y minus x plus y minus x into y plus x, again using the identity here. So we can take out y minus x from this expression, and we get y minus z into z minus x into y minus x into x plus y plus z. Now based on the options that we had, we change y minus x into x minus y and take out the minus sign. So we get minus into y minus z into z minus x into x minus y into x plus y plus z, and option B is the correct answer. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.